This is a quick follow-up to the previous video I posted on connecting an IDE device, specifically a compact flash device, into my 286 system. As I was looking through some previous designs, I saw that quite a few of them were using a programmable peripheral interface, or a PPI, to connect between the 286 bus and, let's say, a drive, an IDE drive, or a flash type of card, compact flash card. And that was the design approach that I took as I was getting into that. But it seems like the feedback I got pretty quickly was you really don't need that PPI. And that was really probably there for those other designs because they were on an 8-bit processor, not a 16-bit processor, or at least maybe an 8-bit data bus versus a 16-bit data bus. And so based on that feedback, I real quick spun another PCB that should give me a little bit of flexibility and let me experiment with this a bit. And this is still a pretty minimalist approach, and I probably have some things not quite right here, but hopefully this card will have some flexibility to let me experiment, I guess. And so maybe let me start out with the ISA edge connector up here in the corner. On this, what I have done is I've added a pin header to basically connect to every single pin of the ISA slot. So when I plug this card in, I can access any of the signals by soldering a wire in and taking it to wherever I need to on the card. So that's just going to give me some easy flexibility and might make this a more general card that I can do other things with too as I want to experiment with things. Then over to the right, I'll zoom into here. This is the pin out of the IDE connector, the 40-pin IDE connector. And here is that connector in my schematic. So I've gone ahead and hooked up all of the actual signals, and these are coming right off of that ISA bus. So I'm coming right from the ISA bus with my 16 data lines, my IO read, write, ready, and then this enable I am connecting into pin 37, which is this cable select. Sometimes I see it referred to as cable select 0 or cable select 1 in this graphic that I have here. So that allows me just to choose when is this device actually enabled. And there are some other things that I'm maybe not sure yet what I'm going to do with. So there's some of the DMA, there's the request and acknowledgement for DMA, there's interrupt support. I just ran those to a quick little 2-pin header so that I can later pick an appropriate wire off of those ISA slot headers and just run over the wire for whichever DMA channel I want to use or IRQ number I want to use. So no jumpers, no direct connections for now, and just I'll run those little wires as I get to that stage of trying to test out DMA. Initially, I won't use DMA at all, though, and I don't think I'll use interrupts to start out unless I need to. And then there's some addressing that I have to hook up, and my assumption is with the 286, I need to have those shifted by 1. So what's address 0, I'm bringing in A1, address 1 is A2, and then address 2 is connecting to A3 from the ISA bus. And if it ends up that's not right, again, I have those 2 headers where I could just quickly disconnect that and run it to a different address line if I needed to. I think this is correct, though, A1, 2, and 3. Connect to A0, 1, and 2 on this connector. And those are marked over here, DA0, DA1, and DA2. And then there's some other signals like a 38, which is another type of a cable select. And basically I'm using just this one over here. So the other 2 of them, there's a CS3 here. And I was thinking there was a CS2 somewhere. But basically I'm just bringing that down to ground. And again, I have a header, so if that's not right, I can change that around later. That's basically what I've done, and this is really tapping. This is going to tap a CF card directly into my ISA bus. Now I have questions, can it run as fast as it needs to, or will I have wait states, things like that I need to worry about, and I guess that's something I'm going to have to learn as I get into this. I did also add a secondary connection. The difference here, though, is I ran the data through a pair of 74 245s. So I'll pull the data off the ISA bus and then bring it in, use it here, bring it out, and push it back out accordingly. And that is for my device 1, which has its enable, and that logic down here for those enables hasn't really changed. I'm going to enable one or the other depending on which address. I can write 2 different IO addresses, and depending on if I'm at D0 or D8, we'll enable one or the other as far as this is concerned. And again, that is selectable. So I think this will give me some flexibility, and maybe I'll have to do other types of cuts or runs when I get into this and learn more about it. But in this case, I'm really trying to do more of this direct connection to the ISA slot over here and the ISA bus. But I think this should be flexible enough. I've got my data lines, and then all these other lines, I have jumpers that I can easily change around and work with as I need to. So what that ultimately turns into then is a card that looks like this. And let me reopen this. And so then I have this. Now all of these that you're seeing female headers, none of those will be populated. I'll just leave those as, especially on these over here, all of these that are coming from the ISA slot, those will just be left as places where I could solder in a wire if I decide I need a signal that isn't already going to the right place. So that's what the card looks like. I did also have a question about, should I have mounting holes for those little adapters I might be using for the CF cards. I might use different adapters. So for now, I'm not going to put any mounting holes. And when I place those, I can easily affix those with a little standoff and maybe a little bit of a double-sided tape or other adhesive, and I'm not too worried about the physical holes at this point. And this card is really just kind of a testing, trial, and error, and learn things, and won't be what the final card will look like. I did find some other schematics out there for a 16-bit IDE interface that seem to get quite a bit more involved, so I'll maybe look at some of the things they've done, and maybe in time that stuff will get added in to my card here too. But starting on the simpler side, again, one of these really is connected right into the ISA bus. The other one is running the data lines through these 74 245s. So I appreciate all the quick feedback from everybody on that, and hopefully I understood the comments I've gone through, and this is where I'm at. So right or wrong, this card is the next one that I will have to work with. And like I said, I could probably use this card for other things too. If I'm just doing general building of new circuits, I could easily just solder in the wires I want to pull off the bus and click this into my ISA bus and use that. And so we'll see. Maybe this card will get used for other purposes too as we get into this. But again, thanks everybody for the feedback. Hopefully this is a step closer or not as far away from what I should be trying to get done. And I'll see what kind of issues I have with this when I get it and try to start connecting to a CF card. And again, I'm going to start without DMA support, and then I'll add DMA support at a later time if I can make this work. Maybe one other question that was out there is about trying to get a file system running on this, and maybe ideally using C, C++ for that. I don't know how far away I am from something like that yet, so we'll have to see if that is something I can do or not. My initial plan, though, is to try to find some assembly type of solution for FAT access. I do have a previous video where I started to set up my environment, my development environment or tool chain so that I can do C++ coding, but it seems like in my BIOS and my operating system, if I call it that, there's a whole lot of interrupts I need to support if I'm going to really use C++. So maybe there's something a little bit lower level C-wise that I could be looking at, and I'll continue to research that and see if I've got other choices here. So more to come.